All right, in example 3, again, we're going to identify what kinds of functions we have. We have a polynomial, and we have a logarithmic. L comes before P in the LIPET hierarchy, so that's going to be our U. And dv is going to be x dx. Now I find du, and I find v, and now my integral is going to be u times v minus the integral of v du which simplifies to, let's see, 1/2 integral of x dx. And I integrate that. And I simplify. And there is the integral of x log of x. All right, on to example 4. Now in this one, I only have one function. I have a logarithmic function. So the way we're going to treat this is the logarithmic function is going to be our u, and the dv is going to be the polynomial, which in this case is just 1. You know? And so there's our u and our dv. And then we find du. Oh gosh, what's the derivative of the base 5 logarithm of x? Well, that's going to be, let's see, natural log of x, natural log of 5, that's going to be 1 over x natural log of 5. And the integral of dv is just going to be x. Alright, and now the integral is going to be u times v minus the integral of v du. I'm just going to go ahead and simplify this right away. It's just going to be dx over the natural log of 5. And I can bring the constant natural log of 5 out in front. And integrate that. It's just going to be 1 over the natural log of 5 times x. Or x over the natural log of 5. Now I could shift this up a little bit. I can rewrite the base 5 logarithm of x as natural log of x over the natural log of 5. And I can combine this into a single fraction over that one denominator if I so choose. Really, I'm okay with either or here. All right, there's example 4. And example 5. We have an inverse trigonometric. Again, this is one, where we don't have anything else. But anytime I have a standalone logarithmic or inverse trigonometric, integration by parts is going to be the way to go. And so that's du is 1 over 1 plus x squared dx here. And v is going to be x. And so our integral is going to be u times v minus the integral of v du. And then this I can integrate using substitution. Now, since I already used u and v, I'm going to make a t substitution. Substitute the denominator. And then dt is going to be the 2x dx. So x dx is equal to 1/2 dt. So this turns into x arctangent of x minus 1/2 integral of dt over t, x arctangent of x minus 1/2 natural log of the absolute value of t plus c. And then we bring our t back here. And actually, we don't even need the absolute value signs here because we're guaranteed that what's inside the absolute value sign is always positive. And so here's where I'm going to stop with my final answer. All right, that's the end of this video.